Every company is suddenly an AI company. Software companies describe themselves as AI platforms. Cloud companies say they are building the infrastructure for the AI age. Banks talk about AI-powered fraud detection. Car companies talk about autonomous intelligence. Consulting firms sell AI transformation plans. Even companies that have barely changed their product now describe themselves as if they are one step away from building the next ChatGPT. At first, this seems ridiculous. A company adds a chatbot to its website, and suddenly the product is AI powered, while another company adds a smarter search bar, and suddenly it becomes an artificial intelligence platform. A software business connects its product to OpenAI's API, and investors are told that the company is now part of the AI revolution. Across corporate websites, investor presentations, and earnings calls, the same word keeps appearing again and again: AI. But the strange part is that this moment is not completely fake. Artificial intelligence is real. The spending behind it is real. The infrastructure is real. The market reaction is real. That is what makes the current AI rebrand so powerful but also so dangerous. Some companies are genuinely building the future. They are developing chips, foundation models, cloud infrastructure, data centers, automation tools, and entirely new business models around artificial intelligence. But many others are doing something much simpler. They are borrowing the label. They are taking an old business, adding the word AI, and hoping the market treats them like the next NVIDIA, Microsoft, or OpenAI. The reason they are doing this is obvious. There is too much money attached to the word. According to the International Energy Agency, AI-related companies in the S&P 500 gained around $12 trillion in market capitalization since 2022. That means a massive share of the stock market's recent growth has been connected to companies investors believe are tied to artificial intelligence. When one word is connected to trillions of dollars in market value, every CEO suddenly learns how to say it. This is not the first time this has happened. During the dot-com boom, companies wanted to become internet companies. During the crypto boom, companies wanted to become blockchain companies. During the software boom, every business wanted to be a platform. Now every business wants to be an AI company. The pattern is always similar. A real technology appears, investors get excited, a few companies become extremely valuable, then everyone else tries to attach themselves to the trend. But this time, the situation is more complicated because AI is not just a speculative token or a simple consumer trend. It is a general-purpose technology. It can write text, generate images, analyze data, write code, automate customer service or support scientific research, improve manufacturing, and change how companies operate. That means the hype has a real foundation, but that also makes it much harder to separate real AI businesses from AI marketing. Almost every company can use artificial intelligence in some way. A law firm can use AI to summarize documents. A restaurant chain can use AI to predict demand. A bank can use AI to detect fraud. A retailer can use AI to recommend products. An insurance company can use AI to process claims. A car company can use AI in driver assistance, manufacturing, logistics, or customer support. But using AI does not automatically make a company an AI company. That distinction is where the confusion begins. If every company that uses spreadsheets is not a spreadsheet company, then every company that uses AI is not automatically an AI company. A normal business can use AI as a tool. A real AI company builds its competitive advantage, revenue model, or infrastructure around artificial intelligence. This is why the market is becoming messy. Real AI adoption is happening, the numbers prove it. Among large companies in OECD countries, AI adoption rose from slightly over 15% in 2020 to nearly 40% in 2024. That is a huge increase in only a few years. Businesses are clearly experimenting with AI, integrating AI into workflows, and trying to find ways to reduce costs or improve productivity. But the same data also reveals something important. AI adoption is uneven. Large companies are moving much faster than smaller companies because they have more money, more data, more technical staff, more cloud access, and more ability to integrate AI into their existing systems. Smaller companies often do not have those advantages. They may not have the expertise, they may not have the internal data structure, they may not even know where AI would actually improve the business. So many companies take the easiest route. They buy an AI tool, they add an AI feature, they update the website, they change the product description, they mention AI in the earnings call, and suddenly they are presented as part of the AI economy. That does not mean the feature is always useless. Sometimes it can be genuinely helpful. It might improve customer support, speed up internal work, or make a product easier to use. But there is a major difference between AI improving a business and AI becoming the business. That difference is what investors have to figure out. Wall Street does not only reward companies for being efficient, it rewards companies for having a story. Right now, AI is the strongest story in the market. If a company can convince investors that AI will increase revenue, reduce costs, improve margins, or expand its total addressable market, it can receive a higher valuation. Analysts may become more optimistic. Customers may see the company as more innovative. Employees may believe they are working on something future-focused. So the incentive is clear. Even if AI only plays a small role in the business, companies are motivated to make it sound central. They do not want to look behind. They do not want to admit that AI might only be a feature. They want to be valued like AI is the entire future of the company. This is where the story becomes more than just marketing. Because behind the AI rebrand, there are two very different realities. On one side, there are companies using AI as a branding tool, and on the other side, there are companies spending tens of billions of dollars to build the physical infrastructure that AI actually requires. The difference between those two groups is enormous. The real AI boom is not happening inside corporate slogans, it is happening inside data centers. This is where the difference between a company that says AI and a company that is actually building AI becomes obvious. A business can add the word AI to a product page in one afternoon, but building real AI capacity requires chips, servers, cooling systems, networking equipment, power contracts, land, water, engineers, and billions of dollars in capital spending. This is why the biggest technology companies are spending at a scale that looks almost unreal. Microsoft, Google, Amazon, Meta, Oracle, OpenAI, and NVIDIA are not treating AI like a small software upgrade. They are treating it like the next industrial platform. The companies at the center of the boom are not just improving apps. They are building the physical foundation that allows AI models to be trained, deployed, and used by millions or billions of people. The reason is simple. Modern AI is extremely compute-intensive. When someone types a prompt into a chatbot, generates an image, asks an AI tool to write code, or runs a business automation workflow, that request has to be processed somewhere. For small tasks, some AI can run on a phone or laptop. But the largest models, the most advanced tools, and the heaviest business workloads depend on huge clusters of specialized chips inside data centers. This is where the AI story becomes much more physical than most people realize. AI is often presented as something invisible, like software floating in the cloud. But the cloud is not magic. It is someone else's computer inside someone else's building, connected to someone else's power grid. And in the AI era, those computers are becoming more expensive, more power-hungry, and more specialized than ever before. Traditional data centers were designed around normal cloud workloads, websites, apps, storage, streaming, databases, and enterprise software. AI data centers are different. They need massive amounts of computing power, huge data throughput, specialized chips like GPIOS and TPIOS, scalable storage, and high-speed networks that allow thousands of processors to work together. Cisco describes AI data centers as specialized facilities designed to support artificial intelligence workloads, which require high computational power, massive data throughput, storage scalability, and energy efficiency measures. That sounds technical, but the business meaning is simple. AI does not scale like a normal app. If an ordinary software company gets more users, it can rent more cloud capacity and expand gradually. But if an AI company wants to train a frontier model or serve millions of AI requests every day, it needs an enormous amount of hardware working together. It needs the infrastructure before the revenue fully arrives. That is why big tech is spending so aggressively. A research report on big tech data center spending described the current build-out as no longer a normal cloud expansion cycle, but an AI infrastructure race. The bottlenecks are no longer just land and fiber. They are power, GPUs, high bandwidth networking, and time to capacity. This is a crucial point. The companies really competing in AI are not only trying to build better software, they are trying to secure scarce physical resources. They need NVIDIA GPUs or their own custom chips. They need enough electricity to run those chips. They need cooling systems that can handle higher rack densities. They need networking that can move huge amounts of data between processors with extremely low latency. They need data center space ready before demand arrives, and they need all of this faster than their competitors. That is why the money is so large. Microsoft has discussed tens of billions of dollars in AI-enabled data center spending. Alphabet's capital expenditure has climbed sharply as Google invests in cloud and AI infrastructure. Meta has guided toward massive capex as it builds AI training capacity. OpenAI's Stargate project has been described as targeting hundreds of billions of dollars and gigawatts of power capacity over several years. Oracle has also become deeply involved in AI cloud infrastructure, especially through large data center commitments and partnerships. These numbers matter because they show what real AI competition looks like. And if a company says it is an AI company but has no infrastructure strategy, no data advantage, no model advantage, no distribution advantage, and no clear path to monetization, then the label may not mean much. Meanwhile, the real AI infrastructure companies are spending like railroads, oil majors, telecom giants, and power utilities all at once. This is one of the most misunderstood parts of the AI boom. People think the AI race is only about who has the smartest chatbot. But behind the chatbot is a much bigger race over infrastructure. The model is only one layer. Underneath it are chips, under the chips are servers, under the servers are racks, under the racks are cooling systems, under the cooling systems are data centers, under the data centers are power grids, And under the power grids are energy contracts, utility negotiations, permits, and physical construction. That is why NVIDIA became so valuable. NVIDIA is not just selling chips in the normal sense, it is selling the engines of the AI economy. Its GPUs became the core hardware used to train and run many of the most advanced models. But even NVIDIA's chips are only part of the system. The chips need high bandwidth memory, networking, storage, cooling, and software. Once AI clusters become large enough, the entire data center starts to behave like one giant computer. This is why networking companies also want to be seen as AI companies. Nokia's material on AI data center networking explains that AI training and inference are not only compute intensive, but also dramatically increase the performance requirements of the networks supporting them. AI workloads need high-speed, scalable switches, low-latency connectivity, and reliable network automation. In other words, if the GPUs cannot communicate efficiently, the expensive chips sit idle and the economics get worse. That is the hidden cost of AI. Buying the chips is not enough. The chips have to be connected, cooled, powered, maintained, and kept busy. If a company spends billions on hardware but cannot keep utilization high, the investment can become a financial problem. The entire business depends on turning physical infrastructure into useful AI output. This is why the AI boom has started to look less like a software trend and more like an industrial build-out. Data centers are being planned like factories. Power access is becoming a strategic advantage. Cooling technology is becoming a competitive issue. Chip supply has become a geopolitical concern. Even electricity grids are now part of the AI story. The International Energy Agency makes this point directly. There is no AI without energy. AI model training and deployment happen mainly in data centers, and those data centers consume large amounts of electricity. The IEA estimates that data centers consumed around 415 terawatt hours of electricity in 2024, about 1.5% of global electricity consumption. By 2030, that figure could more than double to around 945 terawatt hours in its base case. This is where the AI rebrand starts to look strange. A small company can say it is using AI because it added a generative feature. But the companies actually powering AI are making decisions that affect electricity demand, grid planning, semiconductor supply chains, and global capital markets. The scale is completely different. The IEA also notes that a typical AI-focused data center can consume as much electricity as 100,000 households, while the largest data centers under construction can consume many times more. That is an extraordinary way to think about artificial intelligence. A chatbot may feel weightless to the user, but the infrastructure behind it can have the electricity demand of a city. This changes the business logic of AI. In previous software waves, the best companies often had extremely high margins because software could be copied and distributed cheaply. Build it once, sell it many times. AI is different. AI software may scale digitally, but the compute cost behind it can be enormous. Every query, every generated image, every video, every coding session, and every automated task has some infrastructure cost behind it. That is why companies are racing to reduce the cost per token, the cost per inference, and the cost per useful output. The winners will not only be the companies with the best models, they will be the companies that can deliver AI cheaply, reliably, and at scale. That means owning or controlling the full stack: chips, cloud, models, data, software, and customer workflows. This is why Microsoft's relationship with OpenAI matters. It is not just a product partnership. It is a way to connect models with cloud infrastructure and enterprise customers. This is why Google's AI strategy matters. It has its own models, its own TPUs, its own cloud, and huge distribution through Search, Android, Gmail, YouTube, and Workspace. This is why Amazon matters. Issues by AWS already runs a massive cloud business, and AI demand gives it another reason to expand infrastructure. This is why Meta is spending so heavily. It does not sell cloud infrastructure in the same way, but it needs AI to improve ads, recommendations, assistance, and future products. These companies are not adding AI because it sounds good. They are adding AI because it could reshape their economics. If AI improves search, cloud services, advertising, productivity software, coding, customer service, and automation, then the prize is enormous. But the cost of chasing that prize is also enormous. That is what separates the real AI companies from the AI tourists. The AI tourists want the valuation premium without the infrastructure burden. The real AI companies are accepting the infrastructure burden because they believe the long-term payoff will be worth it. But this creates a new risk. When companies spend this much money before the revenue fully arrives, they are making a massive bet on future demand. They are betting that customers will use more AI, pay for more AI, and integrate AI deeper into their businesses. They are betting that the infrastructure they build today will still be valuable when the next generation of chips and models arrives.